Yeah, thank you everyone for this great attendance and even joining our testing efforts. See people trying with a car outside on the Everest deck. So I would love to introduce you why we do it, what we do, and who joins that effort. And let's start not that small, let's start really big. I mean, you have heard so much about the power grid, how that will change, and what are the struggles with getting it right. And this is really, really huge. If we drive full electrification of all road transport, this is like plus 30, plus 40% of electricity demand. You will have some upsides on saving somewhere else, but it's huge. So that could really stress the grid. If you do it wrong, if you do it right, we can save climate and we can save the grid. And so this e-mobility, electrification, doing it right is really core to humanity. The problem is, at the moment, we're not doing a good job as an industry. Like, I think Germany official numbers was something like 10% downtime on public chargers, North America even up to 25%. So we clearly can do better. And behind the scenes, I sometimes even hearing about, yeah, these numbers might be a bit underestimating, it's actually even worse. So we can do better. Give you two examples from the field, what we experienced working with industry clients. We'll try to anonymize that. We had one vendor who tested all the compliance to backends. I think actually we have multiple companies, and everything worked fine. First customer hit them, and then this particular new backend wasn't supported. And changing the stack was then impossible. Stack vendor couldn't really help. So at the end of the day, we really saw people couldn't sell their hardware because a particular backend was not supported. So we saw that multiple times. So lesson learned for us here is standard doesn't mean it's standardized. So yeah, standard is not the full story. Another story, what we saw really in the field is people assembled chargers, took protocol testers, went to labs, got it fully certified, shipped to customers, and it hasn't worked. So we also hear that story a lot, like, oh no, sorry, the Tesla doesn't behave like a protocol tester. It's also testing, a story here is lab testing doesn't save you. So what will save you? And this is the reason why it's so complicated. We tried to do this chart some months ago and trying to map out all standards. And if we missed some, please let us know, which are relevant for EV charging. From grid connection, cloud connection, AC charging, DC charging, and also the Asian ones here at the bottom. And if you would zoom in, let's say around OCPP 1.6, there's so many extensions to this. So this will get fractal. If you zoom in, you will see way more details. And it's a mess. A rough estimation is, I think, 20 to 30,000 PDF pages you see here on the screen. So good luck getting that all implemented. And you see it's not getting better over time. There's new standards added, but that doesn't mean you can drop OCPP 1.6. You still have to support all of that. And here, to be continued, we see behind the scenes people starting new initiatives for new standards. So it's getting worse and it will stay there for a while. So what should we do? A better standard, right? So we just cover all of that with an even better standard. This is my favorite cartoon for this. So we have 20 broken standards. What should we do? Let's make a better one. The output would be we have 21 broken standards. So this is a non-solution, but that's what the industry is trying right now. So we really, really should change behavior. And I said I'm a physicist and sometimes I'm a bit into charts. So how I would call it is a complexity explosion. You have hundreds of different car brands, hundreds of different charger brands, hundreds of backend systems, hundreds of apps. Everything has to work with everything. Let's say if you have 1,000 here, 1,000 here, and 1,000 here, that's a billion combinations. You can't test your way out of that, not even as humanity, because then everyone has to be a tester. So that's a non-solution, trying to fix that with testing, if we're acting like this. So what else can we do? So what we would need is a single implementation on one line of the wire, because then we don't have this multiplication of combination, then every vendor could test its thing if on the other side of the wire there's only one target you have to test against. But we don't like software monopolies. No one would ever allow something like Microsoft Windows to happen again, such strong closed source monopoly. And we need a lot of flexibility because we are in a fast-moving environment. We don't want to break anyone down. So we think the only solution to this is an open source business model, open source software module, where in the center, that's our recommendation, like on each wire on one end, you make a central solution, and if you do it on the chargers, you will just capture all those 3 and even further complexity points. And you see here the small charger dots still shining through. They can be different. They can just build on top of EVerest. And we think that is a perfect solution. And also business-wise, it really makes sense for those who are adopting open source. Honestly, most of you are already using open source to a certain extent. So who is doing Yocto-based or Linux-based chargers here in the room? I would guess it's a lot of people. Or let's say, ask me different. Who is doing a charger which is not Linux-based? Oh, still. OK. Microcontroller, probably. But that's many using already open source as a base layer. Then you often using black box components, and you have to do a lot of software stack on top. What we're suggesting is scaling up your business process on open source, so you already know as an organization how to do that. Just getting rid of the black boxes, scale this up, and focus on your USPs and not on, software commodity, how it was called today. And if you're doing though, then you're solving this make or buy dilemma. This slide was actually explained to me by a customer. They told me like, in the past we used off-the-shelf libraries or software components. It was great. It was a proven system that was relatively cheap because they made so many of them. But we had a vendor lock-in, and every fucking change cost us $1 million. So no way to continue that way. They want to be new, innovative, couldn't do it. So they said like, okay, we need the huge flexibility. We take all the other downsides into account. That's okay. But then with an open source approach, you can combine that. You are super flexible. You can touch and change everything. But you still have the economy of scale by having mass collaboration, like here in the room. But if you want to do open source, devil is sometimes in the detail. There's multiple ways how you can do open source. I'm now talking about licenses. If you're doing a cross-industry collaboration, you can do it with committees, slow, and I would say also a bit buggy, because you sometimes only see if it works when you implemented it, which often happens after the standardization. And you can do collaboration with code. But how you do that? So in our point of view, there's a couple of license options. You can go full commercial, let's say the Microsoft Windows approach with its downsides. Then there's a GPL license that's really restricted. There's different flavors to it, but in principle, if you want to build IP on top, which you want to keep for yourself, let's say a smart energy management system or some super cool daisy chaining of chargers, those IP has an issue that might get infected by open source, so you have to publish that. I guess no one wants to risk your core IP of your companies by using open source. So there's some ways around that. So you can go to a company who is doing dual licensing, GPL and commercial. So you can try out with the open source. And if you find you're buying the commercial licenses. I think the colleague from Bosch in the morning mentioned that approach. Still, I would say not optimal. Next approach, what you can do is you can go to the opposite way, like open source licenses, which basically tells you can do whatever you want, but just don't sue me. So comes without warranty. That's good. It's on your own risk. So you can build a community on top of that, because, like say, with this dual licensing approach or with proprietary, whoever from the community would contribute code, it would only end up in the GPL, not in the commercial. If you're having only one license and it's open source, you can build a community. You have no restriction for commercial use. But especially with MIT and BSD, there's one downside when it comes to patents. I think Lonica in the morning mentioned Bosch and patents. There's one solution to this, which we also learned from the Linux Foundation. There's a story to this. Something happened like, I think, a decade ago, when a big corporate donated to open source, everyone was happy, and then 5 years later, after everyone used it, they mentioned like, oh look, we have a patent here, and you're all violating it, please pay. So this is like a submarine attack on open source. And the way how you can fix that is also by proper licensing. So giving everyone all the freedom to do with the code whatever you want. But if you're donating back to the community, then you're waiving any IP claims on what you're donating, because that's protecting everyone else. So let's say if ChargeByte contributed to EVerest, you can be sure ChargeByte is not suing you for patents based on what they donated. They might have some patents somewhere else that's out of scope, but this is really protecting the community. And having this approach, I think, was one of the key ingredients why EVerest is now scaling in an industrial application, and all the other, I think there's 2-3 other open source projects for charging. They tried GPL, they tried dual licensing, they haven't scaled, because you can't drive adoption with the wrong licensing. Sounds technical, but it's really core. Yeah, and so this was basically the beginning. To start even a bit earlier, me and my co-founders, we had a startup in the drone space before. We built small flying planes for mapping purposes of construction sites, and we sold that company to Intel 2016, and then something interesting in that industry happened. Initially, everything was closed source, as our drone as well. And then industry disruption happened. Our big mother company, Intel, had to leave the drone space because they have been too slow to adopting to an open source revolution. So basically they got pushed out of business by not embracing and switching fast enough. And also our unit basically got pushed out of the market. That was a lesson to us. So 2020, we finally left Intel. We did a bit of consulting around, ended up with a smaller charger maker, and had to help him to build chargers. We looked at that like, sure, do you need us to create yet another OCPP stack, yet another ISO stack? This feels nonsense. It's reinventing the wheel for the 500th time. Yeah, sure, we can do that, but does it make sense? No. Then basically Cornelius, our CTO, realized like, look, this feels exactly the same as we have been 10 years before. So this Android moment where, sure, there's a big Nokias in the industry, but suddenly a new pattern emerges in the industry and changes everything. We thought like, maybe we can make that happen. So we started coding 2020. We created the company like 3 years ago. We got, with Professor Monti, accepted also in the Linux Foundation Energy, beginning 2022. And yeah, so what happened afterwards? So we had Pionix donating the EVerest project into the Linux Foundation. We gave up the trademarks. It all belongs to them. We gave up to a certain extent the control. Now there's a committee to that. So that was the beginning, like 2 years ago. What happened next? We created the one stack to charge them all. And then we got ChargeByte joining us. Thanks again for the early adoption and embracing our vision. We got that into your controllers. You got big players like Texas Instruments and Phytech embracing that as well. On the TI development kits for their CPUs for charging, they deployed EVerest. We got Seed Studio from China with Beagle boards implementing the reference designs. Like 5 months ago, we had our first EVerest summit here. Quello and the joint office joined EVerest as the next TSC members. I got elected into the Open Charge Alliance board. We now one of the really, really big early adoption projects in LF Energy, which sounds early, but no one ever made it to graduation. So we are, I would say, quite good. Yeah, and that's where we now. So you see in the last months a lot of things happened. And about the joint office, I quickly want to tell because this is really, really amazing for us. So what happened there? The US government, maybe you heard that the Biden administration is putting a lot of money into the economy because of the Inflation Reduction Act. They want to push e-mobility. E-mobility is somewhere between Department of Energy and Department of Transportation. So they created a hybrid office, the Joint Office of Energy and Transportation. They are managing all this e-mobility stuff. And they have the mandate to push that as hard as possible into the market, giving money away. They gave requirements, like every charger has to have OCPP 2.01. You will see a lot of race in North America for that, getting that implemented, getting that certified. But they also did something interesting on top of that. I mean, so far so good, it could also happen in Germany. But the next step they did was really extraordinary. They said, like, okay, if we're putting the burden on everyone to fulfill a standard, why not also giving them a present? Like, here you have a reference open source stack fulfilling that standards. They did their due diligence, they picked EVerest. So now we have a couple of US government engineers sitting on EVerest. They have a couple of project managers from the US government promoting EVerest as the de facto reference design stack in North America. And this, again, it's quite fresh, also gave a huge push into the community. And it only happens because we're not a German startup having a public GitHub repository, because we had a community. So having proper management structures, which are not just one company playing dictatorship, is really key to getting those stakeholders on board. Yeah, and that's where we are now. It's only the logos I'm allowed to show. There's way more happening behind the scenes. It's sometimes really annoying when you say, oh, I have these juicy names and I can't talk about. So, but let's go once through that. ChaDeMO organization, we got the permission to implement that as open source. Open Charge Alliance, I mean, you see where we are right now. We're working with Sharon, we're working with the Joint Office, we're working with Subject. They're using our chargers as testing equipment for testing cars. Trusted Computing Group, it's, I would say, plays a similar role than the Open Charge Alliance, but when it comes to embedded cybersecurity, and they said EVerest is a place to be to improve cybersecurity on charging. National Charging Experience Consortia, they try to harmonize error codes. I think we are one of the first implementations there. We have a lot of universities. You have seen now the KIT today and RWTH Aachen, and we also have some from Malaysia, and also there are quite a bit of people. We have hackers and makers and enthusiasts. Sounds strange, but we're, let's say, dual-hearted. Yes, we know the business environment. We also know the hacker subculture. And it's good to have them as alliance, let me put it this way. And also some of this community joins us. But most importantly, the supply chain. Working with as many possible component suppliers like Phytech, ChargeByte, Huawei, Analog Devices, Texas Instruments, SCU. So there's everyone who has a component which is somehow software related, which should end up in a charger. If we all play together well, we can build drivers and compatibility, so whoever builds a charger can just plug and play components. The software will follow automatically. And with that vision, we got a couple of bigger brands convinced. Quello is using, I think, Intelligent is also now finally on the slide, public. Möller is deploying public chargers with EVerest inside. And behind the scenes, we have tested around 40 backend systems and also talking to big charge point operators. They're all super interested to see EVerest rolled out because it would really help them solving quite some problems in the field. And this ended up in an amazing growth story. So this is a double logarithmic plot. I haven't made this chart. It's just from the Linux Foundation Energy benchmarking tool, where they're benchmarking all the software projects. We are the biggest bubble here in the upper right corner. I think last year we had like 5 to 10x growth. Within 1 year, we have now more than 45 contributing organizations. And I would say on average, we have every 10 minutes a new commit. I haven't benchmarked that number, but every time I'm looking, it's typically below 10 minutes. So how do you manage such a project? I mentioned that Professor Monti is in the technical advisory committee of the LF Energy. This is like the supervision board taking care of all the open source project. They review them once a year, they control, make recommendations, align them, quality standards. But then you have a technical steering committee per project. And this is typically where it ends, if you have not a so big one. And here, for EVerest, you will find Pionix, ChargeByte, Quello, and the Joint Office. And it's also open for other ones. So typically, whoever's in here is electing new members. So whoever is contributing a lot and shown technical expertise can be elected into that board. It's how open source projects typically work. Whoever shows he knows his thing and is interested in managing this can ask if he can join that. And you can always listen in. Everything is public. All those meetings are recorded on YouTube, at least the non-discussion part, and the discussion part you can join live. But EVerest grew so big last year that we had weekly engineering calls with 40, 50 people that was beyond manageability. So I think now we're the first LF Energy project going to the next level, creating working groups, and I think currently we have 5 since beginning of this year: car, communication, cloud, CI/CD testing, framework, and tools. So it scales, and we see good progress there with this new structure. Yeah, and that all led that to the slide from the beginning with all those standards. We got quite a bit covered in green. We have some more in mint, which is currently under implementation or people signed up for. One of my favorite examples is, where is it? The ISO-8 Wi-Fi charging. Here, that one. If you have pantograph or inductive charging, you have to communicate over Wi-Fi between charging station and car. And we don't want to do that. We thought like, it's a bit edge case, Pionix has no time for that. But we found so many companies interested in that. Now they're doing it. So it really works that the community is just doing things themselves. And as I said, it's quite a few people meanwhile. To also give you a quick tech overview, how am I in time? Let's go there. Microservice architecture. So EVerest itself is a module system. So you have different modules which can communicate. A module can expose variables like, oh, this is my current temperature, this is my current temperature. Everyone who is interested can listen. And you can also call commands like shut up or whatever it's be. Each module is a separated Linux process, and we have this firmware layer which is orchestrating that. Normally you would do that by having a big Excel sheet with MQT topics, and then a human readable description, what's inside. The problem is that's not type safe. So if you do something wrong, you find it out really, really late. And what we did, we created a description language where we can abstract away this and make it type safe. You get automatic checking. You can get wrapper code for C++, for JavaScript, for Python, and nowadays also for Rust. Thanks to Quello, you get auto completion. And so also this really made it way safer to even find edge cases. And end of the day, if you're starting up your system, you have a manager framework process. He starts different modules, whatever you configure in your charger as child processes. They all have a library they're compiling against, and those libraries handle the communication with an MQT broker. So this is the technical view, but logical-wise, your modules will just provide tokens or require token validators or whatever it is. So they will call commands and publish variables back and forth. And behind the scenes, we're having this. But even though, if it's MQT or something else, can be changed. So EVerest abstracted this away. So as soon as you're replacing this lib framework, you can also make something else happen here. But how does it look like on the block diagram level of building an actual charger? Let's see if this works. So typically start with a central state machine for the charger. You can set up a lot of configuration properties. Then you're adding different modules. For example, often start with the Yeti driver, which is the RCD abstraction and power on off abstraction for our belay box. You're starting with continuing with the generic energy manager. Let's see what's next. Adding ISO 50118 support, and this recording is just an old RISE V2G stack, which is meanwhile deprecated. Again, I think ChaoJi contributed the new stack here. You're adding authentication support, you're wiring up an RFID manager. So I think this already will give you auto charge, it will give you RFID charging, and it will give you plug and charge almost as soon as you're adding OCPP. So now you have OCPP connection. It can do remote start and remote stop if you edit that. And I think next pictures we will add the system module, power meters to make it a complete charger. So let me skip that. So at the end of the day, you're ending up with a configuration of an entire charger with different modules. Like this is a simple AC wallbox. The good thing on this module system is you can also build something way more complex. So this example, we have one AC charging port, one DC charging port, and it can just use the same building blocks to build something different. We have some users who now also went through the OCP 2.01 certification, which only used, let's say, an OCP module and 100 clients all in one machine. So you can also build like entire site managers out of that without ISO in the loop. Would work the same way. And something really interesting and also fun for engineers to use, all the hardware-related modules, there's simulation versions of that. So if you don't have an RFID reader next to you, just use a simulated one. If you don't have a charger next to you, use a simulated hardware abstraction. You can also use a simulated car. That means in a Docker container, you can run an entire charger plus an entire car and, for example, automatically test your backend systems. And using this as a reference design for testing the backend system. I think, yeah, we had multiple talks mentioning that today, that they did this. And if you're now an engineer trying to bring EVerest to a charger, you can have, let's say, one team taking care of the RFID reader, keeping everything else simulated. The other team is replacing the ISO 15118, or the other one is replacing the power meter. You can all do that in parallel. So when all those modules are done, you can plug it together and you have your charger running. So you can decouple things in engineering. And to also quickly preview things, if it works, you can use Node-RED to quickly click a user interface together. I think this we did for a trade show demo of Texas Instruments, just in one dashboard, a quadro charger with cars inside. Was super easy. But EVerest is huge. I think last time when I did this slide, we had 32 public modules. We had 34 different repositories, almost 1 million lines of code. So if you look on these graphs, what do you see here? Once you see here the EVerest framework as a drawing pane, you see the module system, basically as there are boxes. You're seeing a couple of default modules. And some of those modules are in their backend connecting to different libraries from the EVerest ecosystem. For example, the Slack module is calling the lib Slack and the lib FSM final state machine. The ISO 15118 module is calling lib ISO 15118 or OpenV2G. So this is how it's orchestrated. And we typically highly recommend people, yes, you can also use those libraries standalone and not adding EVerest on top of it, let's say the EVerest framework. But so far, everyone we saw doing regretted it afterwards, because you will spend so much time to just use libOCPP, which is kind of a protocol translator, taking packages in and out to the internet and offering a C++ API to connect to it. But it don't give you the state machine in the center. So whenever you consider using EVerest, please think at least 3 times if you just want to use the library, because you will missing out on so much. So to put this all together, we have many protocols in EVerest we support. We have many language bindings. We have this building blocks for the use case. We have the simulations, Node-RED for prototyping. We have a nice energy management. I have not even shown to you. With a Flutter-based user interface, it's all tested. You can configure different situations. It's running on all kinds of CPUs, and it's also running on all kinds of Linux systems. While we see in the field, 99% is just using Yocto. So that's the industry standard. So what's next with EVerest? Short term, we are working on getting ChaoJi ready, Rust and custom protocols, so for payment terminal integration, ZVT. ChaDeMO, we get a Stump library, and we're doing a lot on OCPP and ISO 15118. And midterm, for sure, we'll do OCP 2.1, remote connections that you can spread EVerest over multiple devices, getting more on ChaDeMO, adding a lot of things on the energy management front. EBus will happen in the next year. IEEE 2030.5 comes from California, and more of this energy management things. Don't want to